for our activity here, we're doing it's the same basic principle determining rockets. So we're talking about action and reaction, Newton's third law. And they can do a similar experiment with this in terms of trying to figure out how much of each reactant to put in here to make this thing happen. Essentially, we're using a small film canister. These came from Steve Spangler. They are using a small bit of alka-seltzer tablet and usually a third or a quarter of a piece of tablet and a little bit of vinegar. You can also use water. I think vinegar works a little faster, so it's better for students who are a little less patient. It's up to you to determine what you want to do. Stacy was just saying that she does a really cool thing with her students in that she gives them the canisters up front and then has them design their own rocket. So they wrap the canister in paper, and then they add fins and maybe a nose cone and all kinds of things. And then when they launch them, they realize quickly that those rockets don't end up going anywhere. They don't get the height they want. So then they have to take it back to the classroom and then redesign it. Use what they've learned and redesign it. And typically what they find out is you don't want to do anything to these. You want to take all that stuff away. You might want to decorate it with a Sharpie or marker or something. But you don't need to put fins on it necessarily, and you don't want to add any extra weight to it because it's such a small item. Unlike the water bottle rocket, which has a lot of force compared to its weight, there's not much mass, not much force going on here. So you add almost any mass to the system, it's not going to go as high as you want. So then they come back and they realize, oh, so we need to strip all this away. That's a great activity for them to learn from. And then they can come back on the third time and then start playing with how much vinegar is the right amount, how much alka-seltzer tablet is the right amount. Does a whole tablet do anything besides waste tablets, or does it actually provide some extra measuring height on these guys is pretty difficult. You have to really use time, so use a stopwatch with that. In this case, so we're using the tablets and the vinegar in here. Typically a third of containers worth of vinegar and about a third or a quarter of a tablet does the good job. The vinegar is already in each one. I'm going to place the tablet in, I'm going to put the lid on it, I'm going to shake it a couple times, and I'm going to turn it upside down. And that's what you want to do because you don't want the lid coming off, you want the tube actually shooting up. We're going to have to go pretty quickly here. And when kids do this, A, they need goggles, and B, they need to go quickly, and then they also need to have patience because sometimes it'll happen quickly, sometimes it'll take more than a few seconds for it to happen. So they shouldn't rush in right away to say, oh, it didn't happen, and then they stand over it, and then it pops and hits them in the head. So we'll see how this goes. There we go, not going fast enough. And there you go. Now, if you have an entire class going off at the same time, you can see how it might be much more exciting for the kids to see a bunch of these things going off at the same time. Generally, when you do this, you're doing it on a sidewalk or grassy area. Make sure you space your kids out and that each group is taking in one little section so that they don't bounce into each other or kind of inadvertently step on someone else's rocket or kick it over while it's going. If they're not sure if it's going to launch, if it's just still sitting there, they just need to put their hand over it like this, and then they can pick it up and pop the top off. Sometimes there's a little bit of leak, sometimes it just didn't get a good seal, and they can retry it from there. So that's the alka-seltzer tablet film canister shot. Again, Newton's third law, but also, again, don't just do this activity. Make sure the kids have to work for it. Make sure they have to do an experiment with it, multiple trials, keeping data, and then make sure they have to design something that's going to help it go the highest distance they can get. Thank you so much.